Hello all, I'm very happy to be here in Verona for the Angular Day event. And I'm also really excited to talk about a new era in the Angular development, which is called the era of standalone APIs. Today, together, we will see an overview of the new and modern standalone APIs that have recently been included, I think it was 2 versions before, in the Angular framework. As Edo mentioned, I have read the official Angular documentation, angular.io, more than roughly 40 times in my career. But you know what? It doesn't matter anymore. Why? Because Angular has a brand new home. And not only that, it has a new logo, a new color, and a new version, Angular v17. If you want to check out the new Angular documentation website, you can go to angular.dev, and me as a GDE and the whole Angular team would be very happy to share your feedback with them. Some things about me. I work as a web development team lead at Plexearth, which is a company based in Greece. I also live in Greece, and particularly in Evia, which is the second biggest island. I am a Google developer expert for the Angular framework since 2020. I also work as a senior Angular tech instructor at HodeHub, a private educational institute in Greece, where we train aspiring Angular developers and professionals to use Angular framework. Last but not least, I am the author of very 2 successful books about Angular, entitled Learning Angular and Angular Projects. You can find both of them in the Amazon website. If you want to connect with me via social networks, you can reach me at my Google developer profile at g.dev/Aristeidis. So, the agenda of my talk, what we will see today. We will make a comparison between NgModule-based application and standalone APIs. We will see how to create standalone Angular artifacts using the Angular CLI. And we will also see how to use a new collection of APIs called functional APIs to create guards, resolvers, and interceptors. We will see how to configure an Angular standalone application with providers and services, some things that we need to take care when we create a library or we use a library in standalone applications, and what some migration techniques in order to transfer from an NgModule-based application into a standalone API one. Okay, looks nice. Now, I want you to have a look at this piece of code and tell me if it looks familiar to you or if you know what this code is all about. I will give you some time. No one? Any guess? That's right. This code is as old as Angular v2 beta 0.0. And what this code does, it actually bootstraps an Angular 2 application using Angular components without the use of NgModules. Let's go through this code line by line together. First, we import the component decorator from the Angular 2/core npm package. Please notice that the Angular library was called Angular 2 back then. Then we import the bootstrap function from the Angular 2/platform/browser npm package. We then use our known component decorator to declare our component and set its selector, myapp, and its template. In the template, we use Angular interpolation syntax to display the value of a public name property that we declared in the TypeScript class myapp of the component. Finally, we have created a main function that calls the bootstrap function, passing the name of the TypeScript class as a parameter. Now, as most of us know, this code didn't finally make it to the final release of Angular 2. As we know, Angular 2 used NgModules to bootstrap an Angular application. Now, if we fast forward a bit to today, in Angular v17, let's see how we can bootstrap an Angular application. Let's go through this code line by line together. First, we import the component decorator, but from a different package. This time, it's @angular/core npm package. We also import bootstrap application from the @angular/platform-browser npm package. Again, we use the component decorator to declare our component, but we, additional to the previous properties, we also add a new property called standalone, and we set it to true. Our main function calls the bootstrap application function, passing the same name of the TypeScript class as a parameter. So in Angular v17, we can bootstrap an Angular application using only Angular components without the use of NgModules. So it is pretty much the same as in the Angular 2 beta 0. If we compare this piece of code with the previous one, we will see that it has many similarities. Actually, the only difference is the bootstrap application that we use and this standalone property that we add in the component decorator. We will see later on what is this standalone property and what it does in the framework. So, what we have so far? We have Angular 2 beta 0, where we bootstrap an Angular application using Angular components, which back then it was a very simple approach and it was easy to write. In Angular 2, we have bootstrap an Angular application using NgModules, which is something that many people, especially beginners, found it very difficult and complex when they started to learning Angular. So the Angular team, after 8 years of Angular 2, decided to bring back the standalone approach. And in Angular 17, we have the situation that we bootstrap an Angular application with the use of components without NgModules. And this pattern of going from something simple to something intermediate, which is not always complex, right? And then back to simple, I have noticed it is a pattern in our everyday lives. Like gaming. Does anyone of you know what is the logo on the right-hand side from which video game? No one? Oh, it doesn't appear, right? Sorry, I'm so sorry. It should be the Assassin's Creed video game, and particularly Assassin's Creed 3. So I'm a huge fan of the Assassin's Creed video game series. When Assassin's Creed 1 came out, it followed a mission-based approach, where the player needed to complete a set of missions, and the game was guided them. So it was very simple and easy to play and enjoyable. When Assassin's Creed 3 came out, Ubisoft, the company behind Assassin's Creed video games, decided to bring a more open-world approach, where the players needed not only to complete a set of missions, but also they could explore and navigate through the whole world, through the whole map of the game. And the Assassin's Creed community didn't perceive it very well because it was not very simple. They needed some guidance, and they found it very complex. So Ubisoft, after 11 years, decided to bring back the mission-based approach with their current game, which was released this October, I think, and it was called Assassin's Creed Mirage. But that's enough with gaming, right? Let's get back to Angular, because this is what we're here. So we have two basic approaches in Angular development: NgModule-based approach and standalone APIs approach. What is an NgModule? NgModule is a container that is used to group features with similar functionality. And when we say features, we mean components, directives, and pipes. So actually, an NgModule provides the compilation context to those features. For example, if a component needs to use ngIf or ngFor, their respective module needs to import it from the common module. In the standalone APIs, this is totally different, because everything that components, directives, and pipes need, they can import it by themselves without the use of a module. So this raises the question, and this question, you can see it very often in other forums and communities. Will NgModules go away? As far as we know right now, NgModules will still be in the framework, but they will be optional. And why is that? Because there are many, many Angular applications out there, and particularly there are about 4,000 applications in-house inside Google that use the NgModule-based approach. So if, for some reason, someday NgModules go away, these applications will be very difficult and time-consuming to update and migrate to the new standalone APIs. Excuse me. So let's see how we can create standalone Angular artifacts using the Angular CLI. And we will start with the most basic one, which is the Angular application. Starting from v17, the command ng-new will create a new standalone Angular application, and it will also enable routing by default. Okay, the image looks great now. As you can see from the image on the right-hand side, the project structure of a standalone Angular application is very simple. It is easy to read, and it has fewer files. We don't have an app.module.ts file. We don't have polyfills, no environments, no unit test configuration. We have our usual app.component.ts files, which is the basic component of our application. And we also have two new files, app.config.ts and app.routes.ts. We will see later on what these files are and what they do. If we run the ngGenerate directive command inside an Angular v17 application, it will create a directive as we know it, and inside the decorator, it will add the standalone property that we saw at the beginning of the talk, and we'll set it to true. This standalone property actually tells to the Angular framework that this is a standalone directive, and it can import everything it needs by itself without the use of NgModules. The same is valid for pipes. If we run the command ngGenerate pipe, it will create a pipe, and inside the pipe decorator, it will add the standalone property and set it to true. It is identical to the directive approach. Now, when it comes to the generation of components, it is a bit different, because if we run the ngGenerate component command, it will add the standalone property, but it will also add a new property called imports. And this imports property is similar to the imports property of the NgModule that we know so far. This imports property contains all things that the component needs in order to be rendered correctly in our application. The Angular CLI by default adds the common module there. Why? Because there are many possibilities that your component will need ngIf or ngFor, and these two exist inside the common module. If you want, you can remove common module and add ngIf and ngFor directly inside this imports array, because ngIf and ngFor are supported out of the box in standalone Angular applications. Similarly, if you want your component to support routing, you can import the router module in the imports array, or you can directly add the respective routing directive, like router outlet or router link. And this imports property is very important because it showcases the interoperability between NgModule and standalone APIs. As we can see here, we have a standalone component that can import an NgModule. This can be done vice versa. An NgModule can import a standalone component, directive, or pipe. So in an Angular application, we can have both approaches to work together. Now, let's see a new set of APIs, which are called functional APIs, and we use them to create guards, resolvers, and interceptors, which are based on pure functions, not class-based, which is more simple to read and write. Let's start with the guards. If we run the command ngGenerate guard, the Angular CLI will ask us what type of guard we want to create, right? So it will say, do you want a can activate, can deactivate, can match? According to the answer that we will give, the Angular CLI will create a function. It will declare it as const, and the type of the function will be according to the answer that we gave. For example, in this scenario, I chose a can activate guard, so the type is can activate fn. In the body of the function, we can write our business logic. For example, in this case, I have chosen to create an authentication guard. In the body, I use the inject method to inject two dependencies, the auth service and the router service, and the inject method is used to inject Angular dependencies into other Angular artifacts without the use of constructors. So then we check if the isLoggedIn property of the auth service is true, and we return true. Otherwise, we call the method parseURL of the router service, and we pass / as a parameter. The parseURL method creates actually a URL tree, and when a guard returns a URL tree object, it actually tells to the Angular framework that they need to redirect to another path, and in this case is the root path of our application. Let's go to resolvers now. If we run the ngGenerate resolver command, it will create again a constant function, but this time it will be of type resolvefn. The resolvefn type accepts generics, so that we can define what type of data our resolver will return to our components. For example, in this case, we have chosen to we have defined that our resolver will return a product type of data. Again, in this example, in the body of the function, we use the inject method to inject product service, and we also extract the ID parameter from the activated route using the parammap.get method. Finally, we combine both of them by calling the getProduct method of the product service, passing the ID of the product that we want to retrieve. Excuse me. And last, the interceptors. If we run the ngGenerate interceptor command into an Angular 17 application, it will create a constant function of type HTTP interceptor fn. And inside the body, we can write our own logic, as I did here, where we use the clone method of the request to add an authorization header in each outgoing HTTP request. Okay. At the beginning, we showed two new files in the project structure of an Angular v17 application, app.config.ts and app.routes.ts. The app.config.ts is used to define, actually to configure our application in response to services and providers. It actually defines what providers and services our application will provide to other Angular artifacts. Let's see an example. The default app.config.ts is just a constant variable app.config, which is of type application config, right? And inside it, in this example, we use the providers property, which is the same providers property that we have in NgModules or in components. Inside that providers property, we add our services and providers that we want to support in our application. For example, in this scenario, we want to provide routing. So we call the provide router method, passing a routes object as a parameter. Also, we want to provide HTTP interaction in our application. So we use the provide HTTP client method. And additional to that, we also want to enable the authentication interceptor that we saw earlier. So we use the with interceptors method inside the provide HTTP client to enable it. Here we can have many interceptors because it is a list. So, excuse me for a minute. The second file that we saw in the project structure was the app.routes.ts. This file is used to, it contains the route configuration of our Angular application. In its most basic form, it's a list of route configuration objects. But I will show you an example, more advanced, because I want to showcase two very important features of the router APIs that came along with the standalone APIs. The first one is that we can lazy load an Angular component which is standalone without using NgModules. So in the first configuration object, we use the load component property, and inside the dynamic import, we pass the full path of our component file, product.component.ts. Please notice that this feature is only available for standalone components. The second feature is that you can lazy load other routes or child routes. As you can see from the second route configuration object, we use the load children property that we had also in the routing modules, but this time in the dynamic import method, we pass the full path of the other routes file, which is, in this case, is customers.routes.ts. Now, some things we need to consider when we are creating a library that needs to support both worlds, NgModule-based and standalone APIs, and what we need to do if we want to use a library that doesn't support standalone APIs. Let's start with the second one. Let's suppose that we want to use a library called ngThirdParty that exposes a third-party module, and this library doesn't support standalone APIs. What can we do? We can go to the configuration of our application, app.config.ts, and inside the providers property, we can use the import providers from method and pass the for root method of the third-party module of our library as a parameter. In that way, we will bring the third-party library inside our application. For creators of libraries that want to support both NgModule-based applications and standalone APIs, for the first case, we can create a shared module that imports and re-exports all the Angular standalone artifacts that we have, components, directives, and pipes. That way, the users of the NgModule-based application, they only need to import this shared module in their application. For the standalone case, we can create a constant variable like shared directives and put all of our component directives and pipes inside the list. That way, users of the standalone application, they only need to import this shared directives variable in their components, directives, and pipes. What about migration techniques? How can we go from an NgModule-based application to a complete standalone API application? Thankfully, the Angular CLI has created a schematic for that. We can run the command generate at angular/core standalone in the root folder of our application or in a specific folder. And this command has 3 modes that we can select to run. The first one is that we can tell the schematic to convert all components, directives, and pipes that finds in this folder to standalone. Then we can instruct it to remove any Angular modules that have been left, because we have already converted all of our components to standalone, and these modules are useless anymore. And finally, we can go full standalone by changing our bootstrap method to bootstrap as a standalone completely. So, to recap, what are some key takeaways from this talk? First, Angular Standalone APIs provide an enhanced and improved developer experience for our Angular applications. It is very simple to read and write, and it is considered a modern approach when it comes to authoring Angular applications right now. They are backwards compatible with NgModules, and this is the real power of the framework, so we can have both worlds in the same application. Of course, there are opportunities to migrate so that we don't fall behind with the updates. And finally, we should never forget that we can use NgModule and standalone APIs according to our needs at the same time. I would really appreciate if you rate my talk and tell me what did well and what didn't, what was bad. And I would like to thank you all for attending my talk, and thank Grusp and my friend Fabio. Thank you.
Thank you. Thank you. Do you have any questions for Aristeidis? One question. Should I? Yeah.
I have a couple of questions. One is about the new dependency injection method, the new inject token we have. I saw that it's still compatible with the constructor method of injecting dependencies. I would like to know if there are any differences, like in performance or anything else, or is it just a code refactor Angular did?
I'm not sure about performance. I think there isn't any.
Okay.
In terms, as we see it as developers, right? For the framework, there may be some advantages. But it has to do more with readability and how you write your component. It's less code. You don't need to have a constructor. You don't need to implement the ng-on-init method. You can just have a variable and assign it to this inject function. Personally, I use inject function only on guards and resolvers. For my components, I prefer the constructor-based approach. But this is up to anyone.
Okay, so both are fine then.
Yeah,
okay.
Sure.
Thank you. I do prefer the new method, the new syntax too.
I'm happy with that.
And the second question is, when you talked about third-party modules, the way to import them if the third party doesn't support the standalone way of doing things, and you said that you have to provide the for root methods, but there are a lot of third-party modules that don't implement the for root method. So can you do that with just the module itself, or it has to implement the for root method?
I haven't seen a use case for using a library without the for root method, so I'm not sure about that.
Okay. Yeah, that's just a couple of libraries I came through that didn't implement the for root. So
most libraries, now that you mention, there are many known libraries that have converted to standalone, and other libraries like NX. NGRX has been converted to standalone. Yeah,
so
and
most popular ones.
Yeah, and I think in the coming months, also Angular Material will start to convert to standalone, because there are many people that use Angular Material, right?
Yeah, that's it.
Thanks for your questions.
Thank you.
Another one?
Hi.
Hi.
I just would like to know what's the equivalent of the for-child root method using standalone component. We see the for root. What's the equivalent if I want to translate the for-child?
I don't remember now. I have used it once, but I don't remember right now. There is also a guide in the old Angular documentation about standalone APIs, and most of the content that you see in this talk has been inspired from this guide.
Okay. Anyone?
Yes. Edo, we have a question online then.
Okay, after that.
Good morning, everyone. I'd like to ask something about a comparison with the NgModules approach, because I found that for standalone APIs, it is pretty awesome for simple components, so less boilerplate and everything. For complex components, actually, for me, I think it doesn't scale really well. So I'd like to discuss if it's actually something that we should consider somehow deprecated in the future, or anyways, something that we should start to use on our everyday life, or if there are actually some use cases when using the NgModules approach is better.
Yeah, for complex-based applications where you want to group components in a complex way, I would prefer NgModules, and this is a use case. This is an actual use case to use NgModules. For example, in all of my projects, I use NgModule standalone APIs at the same time because there are different needs, like you said.
Okay.
If your component needs to have an import array of 10 artifacts, it doesn't scale well. I would use an NgModule for that, or I would create small arrays, and I would group them with different constant objects. For example, I would split all the imports in more variables, and import them. Instead of having 10 components, you can have 3 arrays that contain 3 components each, right? But again, it's the same thing. You have the complexity in the other file. So I would go with NgModules in this case.
I would.
Very nice question.
Thanks.
Okay. We have 2 questions from the online audience. So the first is, from a performance point of view, are there any advantages switching from the NgModule approach to the standalone approach?
Yes, it has been. I think there are applications, especially enterprise and large ones, that have seen 32% performance using standalone components. But this again depends on the application. If you have a small to medium-sized application, possibly you will not see any difference. But for large applications, there will be.
Thank you. And another one is there a possible correlation between micro frontend and standalone?
I'm not aware of something like that. I will need to investigate more to answer that question. If they want to question me, to send me a message, and we can continue the talk
Maybe
there.
connect on LinkedIn or like that. Okay, thank you.
Thank you.
Okay, any other question? No. Okay.
Yeah,
So
There's
please.
one people here.
Where? Oh, sorry.
Hi.
Hi.
Okay. So importing entire modules such as common module instead of single functionalities such as ngIf or ngForm. In terms of bundle size, there are some difference, or tree shaking will do the job?
There are very small differences in the bundle size.
Okay.
Again, this you will notice something like that in large applications. But again, in these applications, as bundle size as is concerned, is not so much as the performance that I answered in the previous question. Performance, we have seen more improvements in performance than in bundle size.
Okay. Okay. Thank you.
Anyone else? No. Okay. So please, a big round of applause for Aristeidis. Thank you.
Thank you very much.
Thank you.